Yo, welcome to the Syndicate. My name is Dr. James Utley. I'm your resident code breaker data scraper here, and we have a project going on called NucleoGenesis, and I want to tell you about phase two in this video. So here we go. Quick background here. Nucleogenesis is preserving and harvesting a T lymphocyte nucleus to then be able to, when I say harvest, I mean trap it in dried blood, in a dried blood spot card, which has been treated to preserve the nucleus or the nuclear material in kind of a function that is like that mummifies them, right? As you can see here in this picture. And then from there, we're going to harvest it so we can synthesize a nucleus. And yes, that technology doesn't exist, but people are working on it now. And so what we're doing is preparation meets opportunity. So collect now, decrypt later is the idea. And what that means is we're going to be looking at a top down and a bottom up philosophy on this. So, which top down means bringing it down to the basic framework from harvesting the nucleus. And then bottom up is having enough information to then give to those synthetic biologists or the nucleus synthetic biology labs to then rebuild the nucleus down in the future for whatever you need it for. Anyway, but this is the project we're going to talk about phase two, which is actually the software component that is needed or that is needed to be developed. And that's where we're going to start. Now, let's go ahead and kick it off. There's kind of a continuum of software that we're going to use, and I'll just talk about a little bit more about the technical part as we go through it. But first off, let's check what this video has to hold. All right, and we're going to switch some screens real quick. We're calling this the builder. Now, let me, because this is a screen recording of an application. All of this stuff is on GitHub, which will be, I'm able to share to those that are contributing to the project. So anyway, this is the as you can see, this is the builder application, which takes, if you will see all of these items here, what we're trying to develop is a blueprint, and that is a series of tests and information that is going to be needed to then next stage is to model. So we're going through, we need the full genome, and all of what we have is all the required inputs, all the testing, and it goes through each one of these, and it's required. This is a required asset to upload to get the check mark. So then it'll log to the database. Now I'll just talk about the database infrastructure real quick as you're watching this. Chromatin assembly, histone markers here, the nucleolus, and so on and so forth. All of this testing that it would need to build a really complete digital file that you could, in theory, synthesize a nucleus in the future. Now, okay, so with that said, is the database infrastructure. It will log everything in the database, and which is MongoDB. So it's either Atlas or an MCP server, and it'll just keep everything that will be collectively used. Now, you'll get an uncertainty and a credibility guidance, which has some machine learning predictive capabilities. Therefore, that is your final output logged to the database. And what we're going to do is we're going to move on to the next part, which is here's the sampler. So this is just a kind of a regular, as you're controlling batch to batch lots, right? You're going to need a place it's kind of your master handler where you're going to log all this demographic data. You're going to log on how you're assessing quality control. Because as you remember, I said that we have a card that will be intake, and you need to take all those quality data so you can see it, so you can assess the quality for sample quality, and it'll print out a beautiful batch for you that you can keep with the records, etc., so on and so forth. And we'll get to the end here and we'll move to the next part, which will be located. Oh, okay. This is the synth. So we have completed all of the data intake. We have provided it to the reconstruction module, which I'll show you here next, which is the coolest one. And then we're statistically inferring some of the gaps that we need to be able to synthesize, or in theory, synthesize a nucleus. And this is the program in which will aid us in doing so. So it controls runs and pipeline runs, so data pipeline runs, for training of the model, some what's completed, what's failed, all, manages all the artifacts. So in theory, the output from here after it's doing a bunch of API calls is you'll be able to provide enough information for the downstream synthetic biologist to then reconstitute a nucleus of uh, in this fashion. Okay, now let me grab you to quickly look at. Okay, yeah, and this is the reconstruction module. So this is just a landing page. And what it does is it takes all the information that you received from the builder and logged all the information from the builder. Then it's going to put you into a module, into something that you can model. Now you'll see that this is on an axis for some measurements, and this is far, far from perfect, but this is the idea. Okay, so now we're putting the membrane on the outside of the cell, and that is all information in the center there that we will then infer and continue to build on until we can build this complete file that then is sent downstream to the synth application, so the synthesizing application, which then will provide a final output form that you could translate to the folks that are working on the wet lab part for the synthetic biology. So again, and that is basically it.